In this video, I'm going to teach you how to solve this question. So the first thing I'll do is write out my solution. And the problem says find the Laplace transform of integral of I of t dt from 0 to t. So integral of I of t from 0 to t. So what I'll do now is let f of t be equal to integral of t then I of t dt. Let this be a function of time, which is a function of time. And we know that, recall Laplace transform of f of t is Laplace transform of f of t is equal to integral of exponential minus st times f of t dt from 0 to infinity. Recall this. So now from this formula, we know that f of t is the integral of I of t dt from 0 to t. So we can impute in order to find the Laplace transform. So now be t I of t dt. So the same thing should be integral of from 0 to infinity exponential minus st exponential minus st integral from 0 to t of I of t dt and with t again. Don't forget that this is f of s. This is f of s, and we can continue. So now in order to integrate this, we are going to use method of integration by parts. Using method of integration by parts, method of integration by parts. There are two formulas for definite and indefinite integral. There are two formulas, one for definite, one for indefinite integral. So the first one, using method of integration by parts, the first formula for definite integral, you have this u given u dv over the t of the t is equal to uv minus integral from still to b v du over the t dt. This is the first equation, equation 1, for definite integral. Then the one for indefinite integral is just this. This is the v, the t. So now the uv minus integral of v du over the t dt. Now, since we know that this is a definite integral, we are going to be using this equation 2. We are going to be using equation 1, but just for your also for other equations that may be indefinite, we'll be using the second equation. But for this question, we're going to use the first one. So using the first equation, let's find our u and our dv over dt from this integral here. From this integral, our u is integral of t from 0 to t of I of t. That's our u. And our dv over dt is equal to exponential minus st, and the u over the t now, let's find it. This is equal to d of this I of t dt. Because we know that this is u all over the t. So differentiating this, we are going to have just I of t. We're going to have just I of t. So, and then for this one, integrating dv over dt, this will be the cross multiplying. This will be dv equal to exponential minus st dt. Integrating both sides, this will give us v is equal to minus exponential minus st all over s. Just differentiate the power of the exponents and divide by, for integration, and divide by the original equation. So now that we have found u and the u over the t, the v over the t and v, using this method of integration by parts, we need to find uv from a to b. So let's find it. So finding uv a to b, and we have our b to be infinity and a to be equal to 0. u is equal to integral of from 0 to t I of t dt, while v is equal to minus exponential minus st over s. So let's continue. uv BA is equal to this for the integral we are looking for, dt. This is u and this is v. So 0 to infinity. So now we are going to do upper minus lower from definite integral. From definite integral, this will be upper minus lower limit. So upper, substituting infinity, this will be from 0 to infinity of I of infinity dt multiplied by minus exponential minus infinity s over s. That's for the upper limit. Now the lower limit, you have this integral from 0 to 0 I of 0 dt and then minus exponential minus 0, because 0 times s is 0, so 0. This for lower limit. So now let me tell you something. Exponential minus infinity is equal to 0. So this is 0. Everything here becomes 0. And integral of I of 0 dt from 0 to 0 means that we didn't actually integrate anything. So this is like we moved nowhere. This is also 0. This guy here is also 0. So everything here too is gone. So we have that uv now uv e to b is equal to 0. So now let's find this. Let's find that. So that will give us the u over the t which is equal to integral of from 0 to infinity minus exponential minus st over s I of t dt. This is equal to minus 1 over s integral from 0 to infinity of exponential exponential minus st I of t dt. So this integral is something that has a value, and the value of this integral, recall that this what we said before was this. We said this before, the t is equal to f of s. Yeah, it's also equal to f of s, and it's also equal to the Laplace transform of f of t. So this was what we said before. But now in this case, we have I of t. It's still the same thing. It's just that it will change to I of s. So this now is equal to I of s. This now is equal to I of s. So if you substitute it into this, we are going to have integral a to b v du over the t dt is equal to minus 1 over s times I of s. Yeah, this is it. In place of that integral, this is the value of that integral. So this is it. Now we can find minus I of s over s. Now we can find, now that we have gotten this and this, for this we can now find this. So let's do that. Finally, integral of this dt is equal to, we had uv a to be 0. I explained why. And then we had minus we have minus here in the formula. We have minus here. So that's why I added that minus sign. And then from this other guy, we have minus again, minus I of s over s. So now this will give you I of s all over s. And this is the solution to this question. Thank you for watching, and don't forget to like and subscribe to this channel for more videos like this.